want to quickly go through the drive-through and the salesperson example. I'm going to try and keep this video under 10 or 15 minutes. So let's start with, let me just find this, Let's start with the drive-through question by hand. I'm just going to assume you understand the basic setup. We have our cumulative probability, we have set that up here, we have the order size data, we also have set that up here, we have our information about time to full order, and we have some random numbers generated, and we used from 0.78 to 0.73. So I hope you understand, if you use a random number, for example 0.78, the next one that you're going to use is the next one in line, 0.07, and so on. Let's start with doing this. So we have a time period, we use a random number, we look for the cumulative probability that this number corresponds to, 0.78, that falls in here, so it's 3 customers. Is the service available? Yes. The order size is small. Okay, cool. Now, I just intuitively, obviously, if 3 customers arrive and the service period is 1, we obviously don't have any customers lost, and then there are still 2 people remaining. Service is complete, we get a profit. Okay, so now there are 2 people in the queue. How many people arrive? No. So there are still 2 people in the queue, the service available, 1 goes to get served, they order a medium. There's obviously now 1 person in the queue. Now by the end of this, because they ordered a medium, it's not done, it's only going to be done in the next period. Let's go to the next period. How many people arrive? 1, it's not available. And so now there are 2 people in the queue. This person from before that ordered a medium, they get their medium, we make profit, and now we go to the next period. So what we know is that these 2 people waiting, in the next period, the service will be available. Okay, I just want to make sure I don't go to the wrong row. Again, the next time period, how many people arrive? 1. So there were 2 people in the queue before, 1 person arrives, so there's 3 people in the queue, and there is a service available. So if you go here, you will see that we will have 2 people in the queue, and the order is small, so it's fine. So that isn't too crazy. I think the only interesting part of the algorithm that maybe you would struggle to understand is the number of lost customers. So just think about how we get here and just the logic of it so that it makes sense when we go and do the simulation. So in the previous time period, we had 4 people waiting. However, in that time period, the service was complete. So you'll notice whenever the service was complete in the previous time period, there is a service available in the next period by definition. So let's go to this period in row 26, 8th period. We generate a 0.82. So we then have 3 customers arriving. So remember, what's the situation? We had 4 people in the queue. Okay, sorry, 4. Well, we're going to here, right? Yeah, sorry. So the service is complete. Yes, the service is complete. So we have 4 people waiting from the previous period, but we know that in the next period, when someone arrives, what they will see is not 4 people in the queue. They will see 1 person from the queue moving up, and the person that came before them going into the queue. So for example, in this time period, 3 people arrive. Do we lose 3 customers because the queue before had 4 people in it? No. Because yes, the queue had 4 people in it, but imagine this. These 3 people arrive, so we have a total of 7 people. But because the service is available, one of the previous people that was in the queue goes and starts getting served. So there's really only 3 people in the queue, okay? And so how many lost customers do we have? 2, not 3, okay? Then, 2. So we go to this time period. Now we have 4 people in the queue, and I think this person orders a medium, so it's only going to be complete in the next period. Let's go to this. We get 1 extra person. Okay, so why do we have 1 lost customer? Well, there were 4 people in the queue. The 1 customer arrived. None of those 4 people in the queue moved forward. So I think what you'll notice is, if in the previous period the service was not complete and the queue and the number of people from the previous time period was 4, to figure out the lost customers, we simply take the number of arriving customers. However, if in the previous period there were 4 people in the queue, right? And the service is available. However many customers arrive, for us to calculate lost customers, we just take that number and we subtract 1. I hope that makes sense. So let's go to the simulation. Yeah. Okay, so this was a whole illustration that I did, but I think you guys get it. Okay, so what are we going to do now? Same setup, same everything. Obviously, the only difference is now we're doing the random size generation. Okay, so what are we doing here? The number of customers, we're just using the base up lookup function. I just want to quickly show you something. When you use the lookup function, it actually helps you. So you say v lookup, there we go. It'll tell you, right, what value do you want to look up. So in what we do over here is we don't tell it, we don't give it a value. We say, hey, generate a random value for me and then go look for where it is. But let's say I wanted to make sure that this works. So let's generate a random value of 0.78. So 0.78. Boom. Now it's going to ask me for the table array. I don't use this entire thing. I think you can, but the safest bet is to start from the left, like this, and then you do your semicolon. The index number, we want the output of the number of customers, so I say 2. Now, I don't know why, but yeah, the way the random number generator works, you'll see when I press enter, a whole bunch of new random numbers will be generated. But does this work? Yes. 0.78 is over here, and it's 3 customers. So that's how the lookup function works. Let's just understand all the code we need for this problem. So the number of customers, we just generate a random value, and we go from B4 to C8. And obviously we have these dollar signs here just to make our life easier, because for all of these, we don't want it to become, B5, B6, etc. We just want to keep that specific array to be the reference array. And we have the 2 there. The 2 is just the column. We want an output from the second column, which is the number of customers. Then, is service available? Well, in the first period, we can just say yes. But later on, we just say if, what is I? So in the 13th, row 13, second period, we go to the previous period, we go to column I, and then we just ask ourselves, was the service completed in the previous period? So if I12 equals yes, return yes. If I12 is not yes, which means it's no, return no. I think that's pretty simple. But yeah, I mean, that's a very basic if statement. Remember the if statement? It will tell you this. If you say equals to if, choose that. It asks you what's the logical test, and then what's the value if true, what's the value if false. So nothing too hard there. Then random size generator. So here we're saying if and, so we're basically saying what is our sort of logical test? If B12 is greater than 0, so we had more than one customer who arrived, or more, we had a customer arriving, such that it is necessary for us to generate a random number to figure out their order size, and the service is available, go ahead and generate an order size, because there's a customer and someone is willing to serve them. And so that'll ensure that if either one of those conditions fails, you simply generate the else value, which is 0. But if both of these values are satisfied, we're just going to generate a random number. Okay, so that's what we do for all of these ones. Now, if you go here, for example, if the amount of people, right, that were left in the queue plus the new arrivals is greater than 0, right? So that's the one thing. And, the service is available, go ahead and generate a random number. If any of that fails, return 0. Pretty simple. And then again, we're just using the basic lookup function. Okay, so if D14, if this value over here is greater than 0, do something. If it's not greater than 0, don't bother. If it is, use that value, the random value, and then look up over here. So what are we saying? We're saying G4H6. So this is G4 and this is H6. So again, exactly the same logic, nothing crazy. Service period. So this is also very, very simple. How long is this going to take? So the only reason this is slightly complicated is because the service period isn't always just from the order that was just taken. It's also from the order that we still got from the previous time, right? So obviously, like for example, if someone orders a large in the last time period, the service period is 2. So here they say, okay, if there was an order, what is this, D14? Yeah, so if, all the conditions are satisfied for a person to be able to place an order, which, is a precondition for D14 being greater than 0, then return this value, VLOOKUP D14 greater than that, right? So obviously, in order for there to be a server available for D14 to be greater than 0, it assumes that we've completed any orders from the previous, so that, like, whatever was ordered in the previous period or before that was satisfied in the previous period. We've got a fresh start. We just have to care about the current order and how long it's going to take. However, if one of those things is, if that's not true, so if the server is not available and is still busy preparing something from the previous time period, then return a max. So either return a 0 or F13 minus 1. Okay, so what is F13? So F13 in this instance would just be the previous service period. So for example, if the service was not available, so actually let's have a look at this one, right? This illustrates it quite well. Is the service available? No. So we're going to go to this. This is the ALF value, ALS F value or whatever. So choose a maximum between 0 and F18 minus 1. So this is the 19th column. What is F18 minus 1? Just 3 minus 1, because obviously one time period has elapsed, so let's subtract 1 from whatever it was in the previous time period. But if the server isn't available and we have, or whatever, I don't know what I was getting at, but yeah, I think that makes sense, right? I think you guys understand the logic of the coding for determining the service period. It's either we just take the order, figure out if it's a small, medium, large, have a look at the array, index it, and be like, oh, it's a medium, make it 2. Or, the server isn't available, we're still busy preparing the other one, i.e. it was a large. So, if in the previous period they told the guy, hey, this is going to take 3 time periods, we're in the next time period, we know 1 time period has elapsed, so we know that we just need 2 more time periods, this one and the next. All right, so now I think this, the number of lost customers is slightly tricky, but it's not that bad. It's just the nested if statements can get a little bit complicated. So the first thing here is basically it says if H18 plus B19 is greater than 5. So that is just saying if the number of people in the queue in the previous time period plus the number of customers who are arriving is greater than 5, okay, and C19 is equal to Y, i.e. There is a server available, in order to figure out the number of lost customers, just take the number of people from the queue in the previous time period, add the number of people in that arrived recently, and subtract 5 from it. So obviously, for example, let's say the server is, so let's say there were 4 people in the queue and 4 people arrive, right? But the server is available. What that really means is that there are 3 people in the queue. So 1 person can join the queue. So we had 8 people in total. We subtract 5 and we get our 3 lost customers, because of the 4 arrivals, 1 of them gets to join the queue. So we only lose 3, right? And so 8 minus 5 is 3. However, if, H18 plus B19 is greater than 5 and C19 is equal to no, there isn't a service person available, then you add up the people that were in the queue and the people that arrived, but you subtract 4 from it, not 5. So for example, if there were 4 people in the queue, so let's say whatever was happening in the last time period, someone ordered a large. So there's 4 people in the queue in the last service period, and now 4 people arrive. But the queue isn't moving. There's no server available. All 4 people are going to leave. So we just say 4 plus 4 minus 4. We have 4 lost customers, not 3. And obviously, if none of those things are true, we just return 0. We don't have any lost customers. Okay, let's have a look at the queue. Is it the same for all these? So let's look at the second one. So for the first one, it's pretty simple. We just say the amount of customers minus, okay, okay, how do I put this? If B12 is greater than 0 and the service person available is, and there is a service person available. So basically customers arrive and a service person is available. We just take the amount of customers arriving and we subtract 1, right? So obviously if in the first period, if 4 people arrive, there is a service person available. How many people are in the queue? Just 4 minus 1. But in any other time period or whatever, let's say somehow we were in the first time period, the server wasn't available. You would just say, well, however many people arrived, we just subtract 0, because if 4 people arrived and there's no server, we have 4 people in the queue. So that's pretty intuitive. Let's look at how it works in all the rest of these. So you'll see it works quite similarly. And once you do get the code, you can just drag it down. So it says here, if H14 plus B15 is greater than 5, so if the number of people that were, if we count the number of people in the queue from the previous time period, and we add the number of arrivals, if that is greater than or equal to 5, okay, we return 4, which makes sense, right? Because we can't have more than 4 people in the queue. And if the number of people in the queue from the previous time period, so let's put it like this. If there were 4 people in the queue in the previous time period and 1 person arrives, okay, even if there is a service person available, there's going to be 4 people in the queue, right? There is going to be 4 people in the queue. However, if D15 is greater than 0, so if we took an order, right, or how do I put this? Yes, if we took an order, right, then we calculate the queue by saying the number of people in the queue from the previous time period plus the number of arrivals minus 1. And what this is basically saying is, look, was a service person available? But yes, we're looking at the queue now. So this is a nested if statement. So it says, if something, return a specific value. Else, if something, return a specific value. And if none of those things are true, just return a whatever value. So it says, if the number of people in the queue from the previous time period plus the number of arrivals is greater than or equal to 5, you can just return 4 no matter what, which is true. If there are 4 people in the queue and, I don't know, 4 people arrive, over capacity, just make it 4, right? That's fine. And obviously that wouldn't count. So for example, let's say we're in a situation where you have 4 people in the queue and 1 person arrive, or no people arrive, but the service person is available. The queue would just be 3 people, not 4. But in that situation, we wouldn't have satisfied the condition that the sum of the previous time period's queue plus the amount of new customers is greater than or equal to 5. So if the previous queue plus the new customers is greater than or equal to 5, you can always return 4. Else, if that's somehow not true, if a random number was generated for the order size, which is to say there was a service person available, then you can return. So this would be in the situation where H14 plus B15 is not greater than 5. So we check that condition. If it's not met, let's move on and look for something else. This one says if an order was generated in the situation where the sum of the arrivals in the previous time period's queue is not greater than 5, then what you do is you sum up the previous queue, the new arrivals, and you subtract 1, which makes sense because let's say you had 3 people in the queue and 1 person arrives. Is that greater than or equal to 5? No, it's just equal to 4. But there is a service person available. So what would we say? We would say 3 people in the queue plus 1 arrival is 4, but subtract 1 because of the person that's going to get served. And if none of that is true, just sum up the previous queue and the amount of arriving customers. Then this is now to check if the service is complete. And so the condition is just saying if the sum of the previous time periods So this one says if A15 plus F15 equals A16, or F15 equals 0, return a yes, otherwise return a no. So let's look at the first condition. So if either of these conditions are satisfied, it's fine. So I just want to find F15 here. So F15 is this value. So obviously if F15 is 0, it just means that the service is available. So look here, F15 is 0, the service is available. Now, the other condition is if A15 plus F15 equals A16. So this is to say, if we're in the fourth period and we need one more service period to complete the order, that means that obviously by the fifth time period we'll be done. Now, conversely, just think about it like this. What if this was 3, right? Let's say this was a 3. Well, if we're in the fourth period, we need 3 periods. We need the fourth, fifth, and sixth period. So we would say 4 plus 3 gives us 7. And so in the seventh period, it would be available again. So that's the condition for if. So basically, if the sum of the period we're in and the amount of periods remaining to complete the order is equal to the service is equal to the period in the next period, then yes, we are available. Or if F15 is equal to 0, then yes, we are available. But if either of those, if none of that is true, then return a no. And then the service time index. Let me see if I can remember what exactly this is. If I can't, if this doesn't spring to my mind, please forgive me, but I think I have explained most of what's important. Oh yeah, and then obviously like the profit thingy key. So this is just to say, sorry, I'm jumping around a bit, but just quickly. What we obviously need in order for the profit thingy key to be generated, this would be in all the instances where the service is complete, and there wasn't obviously an order that was taken. So yes, here the service is technically complete, but there's no profit because we didn't sell anything. There was no, yes, 0, the order 0 is complete because nothing was ordered and nothing was delivered. But here, let's look carefully at what they say for profit. So if I15 equals Y, so I15, so if the service is complete, and J15, J is our service time index, and the service time index is greater than 0, look up the, from J4 to K6. So this would be J4, K6. Okay, so look up the time that it took to fill the order. So for example, in let's go over here. In this instance, is this making sense? Yeah, sorry, I'm a bit tired. If D7, so if an order was placed, cool. If an order was placed, oh my god, sorry guys, sorry, I'm confusing service time index and profit. I'm really sorry. Let's stick to profit. Okay. If I17 equals Y, so the service was complete, and J17 is greater than 0, so the service time index is greater than 0. I'm not totally sure right at this moment what is meant by service time index, but yes, if those two things are satisfied, just look up the service time index correlated with the order that was complete, and then assign the profit to that. If I'm not completely mistaken, I believe that, sorry, I just want to check here. So here we have a large which is ordered. It's going to take 3 service periods, where second, first, I think then something went wrong here. I'm sorry. But yeah, I hope that's of some help. Sorry, here about the service time index and profit, it's maybe fell apart a little bit. But I did share this Excel thing so you guys can have a look at it. But I hope that, I think maybe the more difficult one was the lost customers in the queue. So that was 15 minutes. The salesperson one is pretty simple. I'll quickly go through that. So this is just how you do it. I'm not exactly sure what the entire question is, but basically the way you go about it, I think it's about you get 10 calls. Then you generate a random number that lets you know the type of answer that you have. So for example, if you generate a 0.2873, then you fall in this cumulative probability, which is a no. If it's more than a 0.3, it means you get a yes. So obviously if it's a no, we don't move forward. But once we get the cumulative probability in the range of a yes, then we have to ask ourselves, let's generate a random value. And then we have to ask ourselves who's going to answer. And so here's the cumulative probability for that. So if it's between 0 and 0.799, a woman answers. If it's between 0.8 and 0.999, a man answers. So in this instance, we generate 0.4797. So there's a woman who answers. And so now when we look at making sale, we're going to look at this part with the woman. We're not going to look at the man part. So it's a 0.6291. Sorry. It's a 0.6291. And so it falls within this cumulative probability range. So the answer is a no. And let's go and have a look at when we actually get a yes. So it's over here. So we generate 0.9073. So they're like, cool, we're willing to talk to you. We generate another random value, cool, it's a woman. Then we generate another random value, it's 0.0132. So that's over here. So we get a yes. And then we generate another random value that's going to tell us the number of subscriptions. So 0.1016 is associated with this cumulative probability range, which is associated with purchasing one subscription. So then you just buy one and you make profit. And then if you have to go and look at how you simulate it, it's very similar. We take a call, we say, use the VLOOKUP, we say, okay, cool, generate a random value for me, and then go to A3 to B4. So A3 to B4, use the second column. So have a look at if it's between 0 and 0.3 or between 0.3 and 1. So in this instance, whatever our random value is, it's such that we get a yes. Then we go again. So if this is yes, obviously if not, we just don't return anything. But if we got a yes, go ahead and generate a random value, and then go look at E3 to F4 over here. And use the random value that it was generated, see if it's between 0 and 0.8 or if it was between 0.8 and 10. This instance, whatever the random value was, it was between 0.8 and 1, so we got a man. And then for the sale, so this is just a conditional statement, but we're working with this side of it, so it says if C14, this is man, generate a random value for us, go to I8, J9, so I8, J9, and then look at the second column, and then using the random value, tell us what we got. And so in this instance, I believe that the random value generated was more than 0.25, so we get a no. Okay, let's just quickly do another one like this. Obviously, your profit is just, okay, I'm not even going to go into that. But let's go and look at a yes. So generate a random value. Okay, if we get generate a random value, have a look at if we get an answer or not. Generate another random value. Have a look on if it's a woman or not. If it's a woman, look up. Generate for us a random value. Go to I3 to J4. So I3 to J4, and then check where it falls and whether it says yes or no. So in this instance, it fell between 0 and 0.15. So we got a yes. And then we had to ask ourselves, how big of a sale did we make? So if it's a woman and she said yes, go and have a look at M3 to N5. So M3 to N5, and look at the second column, let us know what the random number is. So here, the random number, whatever it was, but it's probably between 0 and 0.6. And so that means that the one was bought. So sorry if this was a little bit confusing. I'm a bit tired, but I hope it does help a little bit.